Electrical metallic tubing, also known as EMT, is a common type of electrical conduit used in various applications. The National Electrical Code, or NEC, sets forth specific requirements for the support of EMT to ensure safety and proper installation. Let's review the NEC guidelines for supporting EMT. NEC Section 358.30 addresses the support requirements for intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and rigid metal conduit, or RMC. It states that conduit runs exposed to physical damage shall be securely supported at intervals of not more than 10 feet. This means that if the EMT run is susceptible to physical damage, such as being located in an area where it could be bumped or struck, it must be supported at least every 10 feet. Now, let's consider NEC Section 358.30b, which is specifically for electrical metallic tubing, or IMT. This section provides different support requirements for EMT installed in certain locations. According to 358.30b, where EMT is concealed within walls, floors, or ceilings, is fitted between access points, or is installed in accessible attics or basements, support shall be permitted at intervals of not more than 6 feet and shall be secured by straps, staples, or other approved means. This means that if the EMT is concealed or located in accessible attics or basements, the maximum support spacing is reduced to 6 feet. It is important to note that the term accessible attic refers to an attic that is readily accessible for maintenance or inspection. Now, let's consider an example. Imagine you have an EMT run that is 6 feet 7 inches long and is unsupported. Based on the information provided, the inspector's citation is correct. The unsupported length of EMT exceeds the maximum allowable distance of 6 feet specified in NEC 358.30b for EMT installed in an accessible attic. Therefore, you would need to install additional supports to comply with the code. To comply with the code requirements, it is recommended to install additional supports within 6 feet of the unsupported section of EMT. This will ensure that the EMT is adequately supported and meets the requirements of the NEC. Firstly, identify the unsupported section of EMT. Secondly, measure the length of the unsupported section. Thirdly, determine the number of additional supports needed to comply with the 6-foot maximum spacing requirement. Fourthly, install the additional supports at appropriate intervals. For example, if the unsupported section is 6 feet 7 inches long, you would need to install at least one additional support to reduce the spacing to less than 6 feet. When installing EMT, it is important to use appropriate support methods. Straps, staples, and other approved means can be used to secure the EMT to the supporting structure. Ensure that the supports are properly sized and installed to provide adequate support for the EMT. In summary, when installing EMT, it is important to understand the NEC requirements for support spacing. For EMT runs exposed to physical damage, the maximum support spacing is 10 feet, as per NEC Section 358.30a. For EMT installed in concealed locations or accessible attics or basements, the maximum support spacing is 6 feet, as per NEC Section 358.30b. By adhering to these requirements, you can ensure that your EMT installations are safe and compliant with the NEC. Always consult the latest edition of the NEC and local codes for the most up-to-date requirements. Always check with the local authority having jurisdiction, or ODJ, for any further clarification. In addition to support spacing, it is also important to consider other factors when installing EMT. These include proper bending techniques, secure connections, and protection from corrosion. When bending EMT, use appropriate bending tools and techniques to avoid damaging the conduit. Ensure that all connections are made securely and that fittings are properly tightened. If the EMT is installed in a corrosive environment, use corrosion-resistant materials or coatings to protect the conduit from damage. Following best practices for EMT installation will help to ensure the longevity and reliability of your electrical system. Firstly, always use the correct tools and materials for the job. Secondly, follow manufacturer's instructions for installation. Thirdly, inspect the installation to ensure that it meets all code requirements. Fourthly, document the installation for future reference. By taking these steps, you can help to ensure that your EMT installations are safe, reliable, and compliant with all applicable codes and standards. Remember that the NEC is a comprehensive document that covers a wide range of electrical topics. It is important to consult the NEC for specific requirements related to your particular installation. If you have any questions or concerns, consult with a qualified electrician or electrical inspector. They can provide guidance and ensure that your installation meets all applicable codes and standards. Firstly, review the NEC requirements for EMT support spacing. Secondly, determine the appropriate support spacing for your installation based on the location and exposure to physical damage. Thirdly, install supports at the required intervals using approved methods and materials. Fourthly, inspect the installation to ensure that it meets all code requirements. By following these steps, you can ensure that your EMT installations are safe, compliant, and reliable. It is important to note that the NEC is not a substitute for good judgment and common sense. Always use your best judgment when installing electrical equipment and systems. If you are unsure about something, seek the advice of a qualified professional. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Firstly, always turn off the power before working on electrical equipment. Secondly, use appropriate personal protective equipment, such as gloves and eye protection. Thirdly, follow safe work practices to avoid electrical shock and other hazards. Fourthly, if you are not qualified to perform electrical work, hire a licensed electrician. By following these safety precautions, you can help to prevent accidents and injuries. The NEC is a living document. It is constantly being updated to reflect changes in technology and best practices. It is important to stay up to date on the latest changes to the NEC to ensure that your installations are compliant. The NEC is typically updated every 3 years, so it is important to review the latest edition of the code on a regular basis. In addition to the NEC, there may be local codes and regulations that apply to your installation. It is important to check with your local authority having jurisdiction, or OJ, to determine what codes and regulations are in effect in your area. The AHA may have additional requirements that are not covered in the NEC. By complying with all applicable codes and regulations, you can help to ensure that your installations are safe and compliant. In conclusion, understanding the NEC requirements for EMT support spacing is essential for ensuring safe and compliant electrical installations. By following the guidelines outlined in the NEC and consulting with qualified professionals, you can help to prevent accidents and injuries and ensure the longevity and reliability of your electrical systems. Remember to always prioritize safety and to seek guidance from qualified professionals when needed. It's important to remember that the NEC provides minimum requirements. In some situations, it may be necessary to provide additional support to ensure the stability and safety of the EMT run. Factors such as the weight of the conductors, the length of the run, and the presence of vibration may all influence the need for additional support. When in doubt, it is always best to err on the side of caution and provide additional support. Also remember that the type of support used can also affect the overall stability of the EMT run. Straps, clamps, and other approved support should be properly sized and installed to ensure that they can adequately support the weight of the conduit and conductors. The support should also be installed in a way that prevents the EMT from moving or vibrating. In addition to the NEC requirements for support spacing, there may also be requirements for the type of support used. The NEC may specify certain types of supports that are approved for use with EMT, and it may also prohibit the use of other types of supports. It is important to consult the NEC and your local AHA to determine what types of supports are approved for use in your area. Furthermore, proper grounding and bonding of EMT is also crucial for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to protect against electrical shock and fire hazards. Bonding ensures that all metallic parts of the electrical system are electrically connected, which helps to minimize voltage differences and prevent the buildup of static electricity. The NEC contains specific requirements for grounding and bonding of EMT, and it is important to follow these requirements carefully to ensure electrical safety. Firstly, use the correct grounding and bonding methods. Secondly, ensure that all connections are made securely. Thirdly, test the grounding and bonding system to verify that it is working properly. By following these steps, you can help to protect yourself and others from electrical hazards. The proper installation and support of EMT is not only important for safety, but it is also important for the long-term performance of the electrical system. When EMT is properly supported, it is less likely to sag, bend, or become damaged over time. This can help to prevent electrical problems such as short circuits, open circuits, and ground faults. By taking the time to properly install and support EMT, you can help to ensure that your electrical system will provide reliable service for many years to come. Firstly, use high-quality materials. Secondly, follow best practices for installation. Thirdly, inspect the installation regularly. By taking these steps, you can help to extend the life of your electrical system and prevent costly repairs. Always remember to consult the latest edition of the NEC and local codes for the most up-to-date requirements. If you have any questions or concerns, consult with a qualified electrician or electrical inspector. In addition to the physical support of EMT, it is also important to consider the environmental conditions in which the EMT is installed. EMT is typically made of steel, which can corrode in certain environments. If EMT is installed in a corrosive environment, it is important to take steps to protect it from corrosion. This may involve using corrosion-resistant EMT, applying a protective coating to the EMT, or providing adequate ventilation to prevent the buildup of moisture. By taking these precautions, you can help to extend the life of the EMT and prevent electrical problems caused by corrosion. The NEC also addresses the issue of physical protection of EMT. In areas where EMT is subject to physical damage, it must be protected by additional means. This may involve installing the EMT in a raceway, using a heavier gauge of EMT, or providing a physical barrier to protect the EMT from impact. Specific requirements for physical protection will depend on the severity of the physical hazards present. Consulting the NEC and your local AHA will help you determine the appropriate level of physical protection for your EMT installation. Always remember that electrical safety is paramount. By following the NEC requirements and using good judgment, you can help to ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and standards.